Let me express my thankfulness to the organizer of this program, Professor Wag, and the university here, the faculty members, bringing out occasion for us to share our experience and the thoughts process. My talk is becoming easier because a lot has been talked about by the chief guest on the sustainability issue, and he has brought out a new concept, at least for us. Some of them may be already familiar. I want to really link the environmental concern with the development which we are doing for the society, industrial, and in other fields. That's most important, how you really. So I will be focusing on sustainability from environmental angle, and I will touch upon also the sustainability of technology as well. With my own experience, the areas where I could come across, I have just tried to bring here the entire thing. I want to tell you that how the environmental concern became important in India. In 1972, there was a Stockholm Convention, and people from various countries gathered, rather head of the countries assembled there in Stockholm, and we talked about environment protection and control of pollution. And from there on, the then Prime Minister, late Srimati Indira Gandhi, started first legislation, environmental legislation in the country in 1974. Most of you may be aware that the first act came to the Parliament Act is Water Prevention and Control of Pollution Act in 1974. And I was the one who could get the opportunity to work right from the beginning, because under this act, various central and state pollution control board are required to be established and do the function as per what have been mentioned in the act. I joined in 1977, and the first board of central pollution control board came in 1976. So in the formative years of pollution control, I was there, and I had to do a lot of challenging tasks in the whatever is the responsibility assigned under the Act and the rules framed thereunder. Okay. Now, since our first Act came on the water pollution control, I will be more focusing on the water quality, and then how we have deteriorated the quality in spite of making a lot of efforts in installing sewage treatment plant, effluent treatment plant, common effluent treatment plant for cluster of industries. What is we are at the moment? Look at the status. We have 317 polluted river stretches. Now these have been identified based upon a network of monitoring in most of the state and throughout the country. And we have this river stretches fall under 9 towns. So the task is gigantic to really restore the water quality of these rivers. Look at it, the challenges at all environmental engineers, scientists to deal with it. I will go into detail and will tell you what we have done it and how we can achieve. Now the segment of rivers that are not meeting the water quality criteria and standards have been identified as polluted river stretches. This is very important. Whatever stretch is falling, say example, in one of the district or in one of the sub-basin of the river, that is to be focused. And sometimes it becomes essential for us to look at from the, the sub-basin of a tributary. The whole purpose of identifying, monitoring and identifies to restore, to have a plan to restore the water quality. This is the objective. Now, before I go further, I think it is very essential to know what we are looking for the water quality. Now, water quality is with respect to various uses. What for you use that river portion? That's very important to understand. And these parameters which are given to you are the minimal one. These are primary quality criteria fixed as back as 1978. So one has to go further for other parameters, but even these still today are good enough if we can monitor these to see that what is improvement is taking place and how far you are improving upon. The best quality which we consider is A, it's called freshwater class A. And then this is the source of water in some of the Himalayan region where you only need disinfection, nothing else, and you can straight away use the water because there may be some coliform, so you too need to remove that. And how do you identify this class A? The least coliform count, that is 50 or less mpn per 100 ml. So this is the measure of the bacterial parameter to really look at it. Well, pH is important, which is more or less same in all classes. The dissolved oxygen. My river is healthy or not? I always say, you simply go and monitor the dissolved oxygen in the river. That's the first parameter I always say to monitor. So it is 6 milligram per liter, which goes down in other classes. And BOD, which is the measure of presence of organic matter, and which is the least in case of class A, is 2 milligram per liter. Because you don't need any removal of the organic matter in this class. Then, of course, our country is very special. We use the river for bathing. Very religious bathings are being organized in various rivers. And look at it, the bathing quality demands minimum of 500 total coliform counts per 100 ml. pH is the same, dissolved oxygen slightly lower and slightly higher BOD of 3 milligram because these, still is a good quality water and there's no problem. The one is C, which is most important. All the water supply comes from the river source at many places. This is the minimum requirement, same as that of coliform organism, same pH, but minimum DO of 4 milligram per liter. Because BOD and DO, they have some relation. If you see you discharge certain wastewater at a certain point of time, and you measure in the river, say 100, 200 or 500 meters away or even kilometers, the things of DO and BOD will change. BOD will go down and DO will increase. So this has got the relation and this has been fixed because our waterworks have only the removal of turbidity and sand filtration by which we remove the particulates matter and improves upon the BOD also. So this is the one which we have. All water supplies are given with a disinfection process. Either you use chlorine or hypochlorite for the reason that you get a safe water at the tap. And one interesting phenomenon I would like to tell you, that the chlorine is still used or hypochlorite is still used for the reason that at the end of tap you must have some residual chlorine, because in pipes, it's an intermittent supply, a lot of organisms could be there. So they should be killed during the process from transportation of waterworks to your tap. This is a very important phenomena, and you observe what is my MPN count when you receive the water at the tap. That's most important for every person who is conscious about water quality. Now, you see that when C is even not met, we are running into the polluted river stretches, which I already mentioned to you. Now, the most important I consider, many parts still not there up to class C. Then what is the class D is? I always say, this is this class D, which is ecological standard. Now, what is ecological standard? pH is still same. Dissolved oxygen not less than 4 milligram, because fish will not survive. That's indicator. There are bio indicators. You need not to go for physical chemical parameters. With the bio indicators or this simple physical chemical parameter here mentioned, these are primary. Of course, one has to go to secondary as well. If there is a specific pollutant going from chemical industries or heavy metal industries, they have to be analyzed. That are secondary parameters. And then you look at the free ammonia. This is most important. 1.2 milligram free ammonia is toxic to the fish. So minimum parameter, if you want to see ecological standard, some life to survive. The river should have some life, and that is the class D. But there is another class, because most of the water in the rivers are utilized for irrigation, industrial cooling, and also disposal of the waste. Now these are the stretches where we see that we need to maintain class E, but there is additional parameters because of irrigation. The total dissolved solid, percent sodium, sodium absorption ratio, boron, they are important for the irrigation. So you see, it's not the BOD or it's not the DO, it is the pH, electrical conductivity, which tells about total dissolved solids, and the boron, very specific to the irrigation part. So this is very important, because until we know the quality requirement, that also to the primary quality criteria, then we will not able to see how we have to really restore our river stretches for our beneficial uses, which are of concern. Several programs have been run by the government. There was the first one which came is Ganga Action Plan in 1986. Then came with the chairman of that board, central board at that time. He brought out a real genius person, and of course professor from Jadavpur University. He was our chairman at that time, and we brought out very meticulously these primary water quality criteria. And I happened to be associated for bringing out the other parameters. And in 2013, international standards were collected, analyzed, and we have given for all the parameters, but the government has yet to look into that and come out with a notification. I will not elaborate much on that, but it was important. Now, what is happening to restoration plan? It is not the government has not done. Many sewage treatment plant, which is the focused upon to install, even upgrade it. And also common effluent treatment plants are being emphasized, and they are coming up. I think there could be around 40 in Gujarat state, similar in Maharashtra, and similar in Tamil Nadu. They are leading states as far as CETPs are concerned. And the individual industries which they are taking care of through their individual effluent treatment plant. And there is a system of continuous monitoring which had been introduced by the government, by the pollution control boards. But what is important? That this river pollution we cannot achieve, control we cannot achieve, we cannot restore our river water quality unless we have to go further. Because the water is getting less and less in the river, we are abstracting, discharging treated water, even with the norms, we will not be able to restore. We have to do something else over that. Let's come to that part as well. Now what is happening is, in Ganga Action Plan, the industries have been asked to achieve zero discharge. I will tell you the example. Tamil Nadu is the most scarcity water, and today's situation is that there is no groundwater available. The city of Chennai, the water supply is being largely provided through desalination plant. It is the only city in the country who is any additional demand, they are dependent upon desalination plant. They are enhancing the capacity, they are coming up with more plant, and Gujarat is going to be the second one. In Jamnagar, I already know that steps have been taken to provide a desalination plant and have the water. Whatever you could get a industrialization between 1985 till now because of Narmada water is all adjusted. Now there are conditions laid down in the consent or in the clearances that you have to have supply either to treat the sewage or recycle, reuse after treatment. These are two specific conditions, and in the Kutch, one of the textile industry was asked that you use the sewage of Gandhidham, untreated sewage of Gandhidham for your expansion. And they have done it. So these are the things which are happening because of scarcity of water. And there also the concept of reuse, recycling is coming up. In case of STBs, treated sewage has to be utilized, either industries or for agriculture purposes. Very important one, because the quality requirement may not be that high. So it can be easy to utilize. But it requires additional infrastructure. You have to supply that treated water, you have to store that treated water, and there we are lacking. You know, if we have intention of doing that, the infrastructure is a must. Government help is a must. So there is a need for sustainable solution through technology and intervention that is already available or it should be developed. This is what is my focus here for the talk. Now I want to tell you there is already a Sustainable Development Goal 2030. What it tells about the sewage treatment, what it tells about the industrial effluent, what it tells about the municipal solid waste. For the cities and communities, what the indicator they are given is installed sewage treatment capacity as per percentage of sewage generated. The simple indicator has been mentioned. For any cities can be projected. For the municipal solid waste generated, the percentage in the processed. Percentage of processed one, then generated. This is simply indicator. You can see the city is better, the city is not better. These indicators will tell you. The percentage of wards with 100% door-to-door collection system. I am happy that these indicators have been brought out in the Sustainable Development Goal. And percentage of wards with 100% source segregation. Very important. I really appreciate as an environmentalist that how these things have been focused in case of municipal solid waste. Now look at the industry's angle. What is the Sustainable Development Goal? They are very simple. Percent of industry compliant with wastewater treatment as per CPCB norms. And that percentage, I am sure, will be quite good one, progressively, with year after year. Then there is another one which they look for is innovation score, as per India Innovation Index. This every industry will have to look as far as the industry is concerned. And then they are focusing to last points on hazardous waste, which is a problem, which is creating a problem of deteriorating groundwater, surface water, and even soil quality. And that's why what they are saying is simple indicator is how much you generate per thousand population, tons per annum, and how much quantity as a percentage is being utilized. Very good indicators, and we'll further go on in the talk. So I want to simply go when we talk about the communities and societies. When I was even I have been traveling in Gujarat, but very important part is everywhere there is a block. Something is being coming up with industrial complex, something is coming up with the commercial and all that. Now, there is no sewer lines throughout. What do? You have to really rely upon decentralized system, even for the institutions like this. So this becomes important. The decentralized system is what it meant for institutional building, accommodative complexes, and hospitals. I always advocate that these are the technologies where it will work. Then utilize your raw sewage in the city. This, I will tell you that Surat is one of the leading city which is entrepreneurs have come up to treat the sewage and supply to industrial purposes. Then utilize on effluent and sewage flowing in the drains. I came to the news that the Haryana State Pollution Control Board is tying up with the TERI to have a use of whatever waste is flowing, wastewater is flowing through the drains, industrial and domestic, because there is a scarcity of water and use it for industrial purpose. The sewage treatment plant, sewage treatment for the purpose of water supply to industrial areas, use of technology. Now, again, here is a technology which is important. If you go for the conventional aerobic system, you lose a lot of power. So that's the important thing, that you have the least power consumption. And there the anaerobic digestion is the most important one. And there is a technology very well established called UASB, Upflow Anaerobic Sludge Banket. It has been utilized. Initially it was with the distilleries, now it is done in sewage and many of the industrial effluents. And there is a simple natural way of treating, is called waste stabilization pond. We'll go into elaboration of that. Look at a decentralized system. Very simple. Anaerobic, you don't need any power. There is a media, it could be stone, it could be plastic rings, but the flow has to be there from the bottom to up. So the entire media is utilized for marketable growth, and then you get the removal of BOD or COD at the outlet. It's simple is to just illustrate. And then there are really good ones. What is happening is this called typical reed bed through macrofats trench. You have plants here, reed. The system is designed in such a way that there is no hindrance of flow in the media, which is basically sand, gravel. And then you at the end, of course the residence time has to be enough. And then the evapotranspiration, the root of these plants act as a providing oxygen. And this system is not only in India, it very well into the community in Germany. I came to know in first time there that they have been doing it. Now it is very well established. There is a document published by Central Pollution Control Board on the root zone technology, and one can make use of it in developing for any kind of a complexes, whether it is academic or commercial or residential. In fact, this has been utilized by the Center for Science and Environment for their training institute at Talwa. Look at the system which is there was in California. It's best to understand the concept. There is a deep pond. What happens to your raw sewage? There is a lot of fecal settleable things. Let it settle so that your algal ponds work more efficiently. And this is called oxidation pond. And then you remove the overflow and treat it with lime, which also acts as a disinfectant, and then use it. The other one which we consider most appropriate, you use UASB. So by that you generate the methane, you are generating the energy out of it, and then the effluent treated from UASB is not good enough to discharge directly into the river. You go for waste stabilization pond, like the one you have algal pond here, and then you use it for irrigation. And there are very efficient system of using for irrigation, very economic way, is drip irrigation. So you utilize the water in more efficient way for the agriculture purposes. Now this is another one, how the septic can work, because each of the compartment acts as its own consortium of bacteria. So you get, the step-by-step treatment, and at the outlet you go. So one is the residence time, and how much is the compartment you built up. And if you use the tubes, basically is for the purpose of a uniform flow throughout the section of the tank. And then of course you have to go for a gravel filter, which also has and then the plants on the top act as a aerobic system, facultative system, and there is attached growth in the gravel, by which the first one doesn't work as attached growth, it is suspended. Second work as attached growth, which is refining the wastewater, and you get a very good water at the end. They are all sustainable. It doesn't require energy except wherever need is pumping, nothing more than that. Now this is the one which have been initiated recently by Terry for the Haryana Pollution Control Board, because their demand was to utilize whatever is flowing in a drain in Faridabad, industrial effluent as the sewage, using the UV photocatalysis method. And that is where the Department of Photochemistry and Photocatalysis of the Terry is working on it. These are all emerging technologies, and it is being claimed that it's much cheaper in terms of you can have a reduced load on your biological system, you can have generally with much lesser installation cost, much lesser operating cost. Now this technology needs emphasis because you generate energy. First time I saw in Tamil Nadu that all the vegetable waste are collected and energy is generated. And that gas is being supplied to the network. I mean, generating electricity is supplied to the network. And then I came to know there are 20 such USB plants, maybe more now, by the study done by Center of Science and Environment, 20 on such kind of biogas generation, the Pune. It's really good to see that how the anaerobic treatment system for the solids as well as the effluents and the sewage is coming up. So in industries, very well established for the food processing industries, sugar, just like even pulp and paper. And also some of the petrochemicals plant, that is PTA, it is very well established. So up to 90% reduction has been seen, but after the USB you need aerobic system for meeting the standards as a discharge norms. But it is very sensitive. One has to understand with sulfide, chlorine, ammonium nitrogen, and you have to maintain the pH. So these are the important part of it, whosoever goes into it. Now this is what I always tell, that the sludge management, where it is good, it is the plant is running very well. If sludge management is bad, sure, the plant is not running well. So I want to emphasize, and there is the technological development is needed for this purpose. The one thing which is being done is dewatering of the sludge, because it's having quite a big percentage of water. Even after thickening of this sludge and dewatering, we are left with 70% of moisture and required to be disposed of. This is a challenge. And then what is happening is, and is a cost, so there is a need of innovative technology. So where is the developmental aspects are needed. What we so far have, one of the option is to go for composting of the sludge and utilize it in the agriculture field, because it has a lot of nutrients in it, particularly the sewage, huge nutrient potential, nitrogen, phosphorus, potassium, and micronutrients needed for the agriculture purposes. But the problem is what to do in the rainy season. Of course, one can build the sheds to continue even the rainy season. And the only problem is that it needs considerable time. So your area requirements become large. Now what one can do is announce this process of composting and introduce mechanization. That's what is the way forward. Other option is to dry the sludge, which is on drying has substantial calorific value, particularly the biological sludge. So if you get a sludge of such energy potential, then it is one of the very good things. You can utilize the same energy for drying of the sludge. So one need to have a system. Or systems already being introduced is wherever there is a waste heat through steam, that drying purpose is used. But always it's not available, and you use the fuel means it's a cost. But you can use the agricultural fuel, agricultural waste as a fuel. On drying you introduce this, so it becomes a cycle. You generate energy, you utilize energy, and what is left behind is already talked about is the ash, which is already rich in the nutrients to go for the electricity. So this I consider as one of the sustainable. The first one is also sustainable, but requirement of land is huge, and since we generate huge quantity of sludge, particularly look at the city sewage treatment plant, how much could be the quantity of sludge? And I will tell you my own experience. As an engineering student, I visited the sewage treatment plant in Dadar, Bombay, in 1970, 52 years ago. And there is anaerobic digestion for primary sludge. And the gas generated from that was being utilized through pipe in whole of the Dadar town, the other locality. So look at the development what we had such a long half a centuries ago. We should have moved much further in that direction. Now I am coming to the industries. You know, the industrial pollution control, when it started as a program, because there is one of the function in the Water Act is the plan and execute the nationwide program for pollution control. When it comes to industries, then it's Central Pollution Control Board is started all along with state pollution control to focus which are the priority areas of industry. And that time there was a case of Minamata disease in Japan. So everybody became conscious, let us control the mercury from the caustic soda production. So in 1984 onwards, the 1984 onwards, the policy was there of India that no more mercury cell process plants should come up, even expansion. And that was the first step taken up. And then in 2003, a stock was taken up. We found there is still some plants working on mercury cell process. And the time was given in 2012. You will be surprised that all plants have been gone into membrane cell process. And mercury is totally eliminated in the production process. And thus, now even as on today, under UNEP, the mercury convention is going on to eliminate mercury from all sources, including using thermometers and all that. Another technological aspect I want to tell you that till 1977-78, the use of hydrolyzed stripper was not there in fertilizer plant producing urea and ammonia. And then this was introduced as an end-on system to control the pollution from fertilizer plant producing urea. And later on by 1990, this became an integral part of the process and getting water so fine that you can use in the boiler. So that was a technological development which took place. And another one was using gas. Now all the plant which was there in the naphtha, feedstock, fuel oil, all had been converted into the gas. So most clean urea production with the latest technology. Chrome recovery in tanneries. This was also attempted with the help of Central Leather Institute. And there are common recovery systems for cluster of tanneries. Utilization of distillery effluent for nutrients in agricultural field, and substitution of chemical fertilizer by compost and drying of the spent wash. This took almost, the program started in the 1980s, and today we have really achieved quite a lot, but there are problems still which need to be sorted out. Adoption of catalytic reduction to eliminate iron sludge. This step, in paracetamol, 1 ton of paracetamol produced generates twice the amount of iron sludge contaminated with chemicals. Start with paranitrophenol. It's a starting material for paracetamol most of us use, and the problem associated with the such production is hazardous waste generated in form of iron sludge, twice the quantity, and is a problem. It's really look for the utilization part. And NCL, National Chemical Laboratory, came. We wanted to use that whatever technology developed in HSC production, but at the time, because of economic reasons, and one industry came forward, but it really did not materialize. And I will not say that situation even today is the same, and maybe this technology needs more refinement to be adopted. Use of nanofiltration for recovery of mining textile industries. When High Court came so heavily in textile cluster in Tirupur and Karur in Tamil Nadu, because the Nuyal river was completely polluted. Groundwater was completely unfit for any use, including agriculture. So they closed all the export-oriented textile industries, and then they have to look for the technology. And because in the cotton textile, the fixation of dye is done by using brine, salt, to call NaCl. So then the nanofiltration is a technology by which your water can pass, the monovolatile sodium and chloride will pass, but the rest will remain. So you can use brine as such, and you will not use fresh salt for the production. So these are all innovative technologies which came forward and industries are using now. I want to come to the last part of the sustainable goal with relation to the hazardous waste and other waste. Now, earlier it was only hazardous waste, but in 2016 the other wastes have been introduced because we are bringing a lot of waste material in the country which have potential to recover and recycle. It could be a lead waste, zinc waste, copper waste, particularly the metal one, and others one. Even paper waste is coming. So what is the approach followed in the regulation of 2016? First is prevention. You prevent by proper technology, proper plant practices, minimize how you can do it. Basically, a plant practice, and as well as technology. Reuse. One of the industrial effluent can be reused for other purposes. Waste can be used for other purposes, or recover the material and utilize. Many list of waste, I will tell you, has a lot of potential of recovery and utilization, and it opens up the research work and the technological development. These are the one which is there is a requirement under the rules of hazardous waste, that you have to contain contaminants and prevent accident and limit their consequence to human being and environment. There's a liability on the industrial production. People provide person working with the site with appropriate training, equipment, and information necessary. The person working should know that this waste is how it is harmful and how to take care by through safety measures. Now, there is a specific rule mentioned to utilize the hazardous and other waste. there's a Rule 9 of the hazardous waste, where a lot of entrepreneurs have come up and utilizing the waste for producing something useful. And there is a system given that for such utilization, the State Pollution Control Board or Pollution Control Committee, Union Territories, can grant authorization, but there is a caveat that a standard operating procedure has to be followed, or the guidelines developed by CPCB has to be followed. And when there is such is not available for particular waste, one has to apply to CPCB so that they will do the trial runs, and then they come out with the SOP, and then it can be used by all the State Pollution Control Board. Then you need not to come again for similar waste to CPCB. They are saying no trial runs are required for co-processing once co-processing standards are notified. This is done in case of cement plant, but in case of the furnaces, there is no standards mentioned so far, so any trial is to be done to use in the furnaces. One will have to come to the CPCB. Now these are all lists for you to look at it, where you can venture into. There is spent solvent, there have been a common recovery system already here in the country. Air pollution control device, dust, residue, how you can utilize. Spent catalysts having precious metals from e-waste. ETP sludge containing platinum is there in the some of the industrial effluent. Spent sulfuric acid, large quantity coming up in the chemical production. Spent acid containing molybdenum in certain industry. Spent HCl, same case. Used anode butt, it is in an aluminium plant. Coal tar, tarry residue in many of the plant. Contaminated containers, barrels. It's very common, and there is a decontamination and people are reusing it. Process and primary ETP sludge. This is extensively done in case of pulp and paper because of the fiber. And aluminum dross is being used for production of aluminium. Oil-based iron sludge, that also been attempted. Spent catalyst containing mercury and mercury waste. Spent sulfuric acid containing organic compounds. There's just a list to tell you, but two very specific things is encountered very commonly is the used oil and waste oil. Used oil is generated whether you have a vehicle, you have a hydraulic machine. There is a waste, the used oil is used and is discarded after a certain period of time, and this can be re-refined. There are a number of plants in the country who is doing, but what is the used oil is fit for re-refining. This is giving in the Schedule 5, Part A of the rules. You should meet this, then only you can refine the used oil. And second is the waste oil. To use as a fuel, because if you use a fuel, there will be a combustion process in the furnace, and then it has to meet the exhaust criteria, the exhaust gases. So the input to the waste oil use, they have clearly defined, including water content, sulfur, polychlorinated biphenyls, polyaromatic hydrocarbons, metals, and sediments. So one has to really treat the waste oil to this specification when you want to use in any of the furnaces or for utilizing the energy. These are some of the potential reuse recycling from the chemical industries: iron sludge, gypsum sludge, activated carbon because there's a lot of fuel value, distillation residue again is a fuel value, spent catalyst solvents, which again you can recover the solvent, otherwise also has a fuel value, carbon slurry, fuel value, sulfur sludge for recovery of sulfur, waste oil I have already talked about, heavy metal containing sludges to recover the metal, spent catalyst containing metals, again recovery of metals. But there is another group, high volume, low effect waste. So the regulations very categorically mentioning about this, to how to manage it. Now, this is basically, we consider 4 basic characteristics for hazardous waste. That is reactivity, corrosivity, ignitability and toxicity in true sense. And some of the waste really doesn't have that, which really have to go for sophisticated or expensive disposal system, but they can be managed with a certain proper guidelines which are available in certain case, need to be developed in certain case by the Pollution Control Board. Now these are the waste, high volume, low effect waste from the industrial operations, like phosphogypsum, which is the source is phosphoric acid plant. Now this gypsum is being utilized in cement industries and other product. Red mud from bauxite refining, tailings from the chrome and lead ore beneficiation, ferrochrome from chrome plants, hyposludge from the caustic soda production, fuel dust from blast furnaces during stainless steel production, lime sludge paper mill, fly ash thermal power plant, which is used for a number of purposes, including utilized in the cement plant, thickener sludge from spore engine plant. Now this is where I talked about the paracetamol manufacturing from for the pharma sector. You get, this is all waste generation factor. How much quantity per ton of product you get it. This is the exercise done by CPCB and available to you in terms of the waste and the source. One can do it. It also has dyes. There is recovery of useful material from the paint sludge from the automobile sector. They are using paint for that. Even the ink for de-inking process, they have already been established. So, there are some of them. I want to come to my last part, because when we do not take care of our hazardous waste and the wastewater for proper treatment and disposal, we end up in several contaminated sites. And in 2003, there was a Supreme Court order to the CPCB that you identify all the contaminated sites in the country and come out with a remediation plan. And then the CPCB started doing certain exercises, and the MoEF took it up in 2010 with the help of World Bank to do it in a systematic manner, the assessment part and remediation part. And they came out with the whole country. There are 320 sites which has initial inventory size of contamination, and 204 sites which are considered to be probably contaminated site based on a screening level. There is a screening level. All the kind of document is available in ministry's website. How to identify contaminated site, what are the screening levels, what are the methodology available. And this was taken up as an exercise by CPCB for certain prominent and very relevant site in the country under National Clean Fund. And it is on, the things have been done, but the inventory told that there are the states like Uttar Pradesh, West Bengal, Odisha, Delhi, Karnataka, Jharkhand, Tamil Nadu, Kerala, Andhra Pradesh, Telangana and Punjab, they have maximum sites in the country. And remediation of these sites are required to prevent, minimize, or mitigate damage to human health and environment. And there is a system to know what is the risk posed to the human being, what is the risk people working in agricultural field, and all that. And that system of analyzing the risk, when you want to remediate chromium in a chromium contaminated site, what level we should come down. So these are the procedural part of assessment of remediation site and coming to a remediation plan. So what are the contaminants found is the metals like chromium and lead, but mercury, cadmium, arsenic, copper, nickel were also there. And the other group is pesticide, fluoride, potash, components, aromatic hydrocarbons, VOCs, volatile organic carbon, phenols, cyanides, which have been also found occurring very frequently. Many sites are located upon groundwater resources. So you have groundwater potential to use, and the sites are on the top of that or close to the surface water. It is of concern to remediate. And then most of them are used for drinking and irrigation purposes and for livestock. Most sites are currently used for industrial purposes, but there are many sites which are mixed use. Look at the challenges which these contaminated sites are. But I would like to tell you how successfully the technique of bioremediation, which is considered to be a sustainable one, has been used in the country. One of the oldest refinery of country is in Assam, Dugboi. It is of the British era. They invented first time the oil in India, in Assam. And first refineries came in that place, and they accumulated the entire oily waste in one of the pond. And when the TERI developed microorganisms to degrade the oil, it was utilized and remediation was done very successfully. And then another which example came is contamination of groundwater with chromium electroplating units in Ghaziabad. And the case came to the court, and then they were asked to remediate it. Now chromium can be remediated on-site and off-site. But if you convert hexavalent chromium, the most toxic, to trivalent, which is remain in suspended form, you do a maximum job of remediation, and the technology was developed by IIT Madras and used at this site, and very successfully it has been used. Then one of the bioremediation, this is an accidental case. When earthquake took place in Gujarat in 2001, the Kandla port had storage of HNP, heavy natural paraffin, and acrylonitrile is a chemical which is intermediate chemical for the acrylic fiber. In that time, I don't know present, that time it was only manufactured by the IPCL. So since leaking started, IPCL was requested that you transfer this content to a new tank. And one of the characteristics of acrylonitrile is, if it comes to the air, it is very toxic. So nobody can do without, as it is, one has to have a lot of protective equipment and do the operation of transferring. But a lot of things gone into the ground, and it has to be remediated. So it's a very toxic component, and to your surprise, there was a technology developed. They isolated certain bacteria, and that was working very well in the lab to degrade the acrylonitrile, and that was implemented on the site. The area was very small comparatively, but it was done to non-detectable level. So this is a big achievement we had, bioremediation. But when I went to Germany, let me tell you, they had one of the sites in East Germany, full of chemicals, industries at site. And now that, and also coal mining, they have created a big cavity which now they have used as a good water reservoir. But if that water reservoir doesn't get contaminated, they are using pump and treat system. They have a slurry valve to prevent contaminated water going into that reservoir, pumping it out, treating it. But then they wanted that we should do something in situ. You can't take out the soil from such a depth. So they thought of doing in situ remediation, and they were working on certain microbes which can degrade the chemicals therein. They were doing experiment, and this was the year 2005 when we went there and saw their remediation technique. Because my chairman asked me what to do for the remediation plan for the country. He said, we need experts with us. And luckily we had a collaboration with the German government, Indo-German collaboration. We were getting exposure, we were getting training program, we were getting expert. So we had one expert on the request from a very good capability, and they saw the site, and then they suggested the things how to go about it. And it's basically an approach how to remediate it. And when I was there, I left in 2006, I made a program that the decision makers also go and see what remediation plan you want to make out and invest on it. And then in 2007, these people in member secretaries and all that, they went to see the site's remediation, how it is done in Germany, to take a better decision. So we were preparing ourselves to go for the remediation techniques and implement on the ground. So end my talk here, and if there are any question, I welcome.